Okay, so it's 10 o'clock, so we're going to go ahead and get started. If there's any problems with the audio, please let us know. So welcome to the summer webinar series. The name of this session is Introduction to Wireshark, and I'm Gans Guzman. I'm a client engineer here at MCNC. You can see my email address is there if you want to contact me. Also, the link to where these webinar archives are going to be is at the bottom of this slide. It'll also be at the end, so if you don't get it right now, you'll get it later, okay? So the agenda for today, we're going to look at what Wireshark is, where to get Wireshark and where to install it, the how and where to capture traffic, capture and display filters, Wireshark analysis tools, and then some. And then we're going to look actually at some packets and do some hands-on analysis. So what is Wireshark? Wireshark is essentially a protocol analyzer, right? So it gives you the ability to actually capture traffic, but not only capture the traffic, but also analyze the traffic in an interactive form. This product is open source, so it's free, and it's available for multiple platforms. And when I say multiple platforms, I really mean Windows, Mac, and Unix. All right, you can read into that whatever you'd like. So where do you get it? I will tell you that if you do a Google for Wireshark, you will see quite a few links pop up. For myself, I always go directly to the source. So www.wireshark.org is the best place to go ahead and download it. I mean, you will find it on CNET, and you'll find it at a bunch of other different places. But to me, going to the source is always best. Okay? When you actually go to the site and you click on download, you'll see that you'll have a lot of choices as to what to download. If you're a Windows machine, you're going to want to download the Windows installer. If you're unsure whether or not you're a 64-bit operating system, which most should be at this point, but some may not, go ahead and just download the 32-bit one. It will work on a 64-bit OS. So don't be confused, or don't be afraid to to go ahead and install a 32-bit if you're unsure. As I said, the downloads for the OS X Mac, they're also in 64 and 32-bit forms. There's also a note on their site that says if you're using OS X, you may want to try the development release. I do know that the GUI is written differently in the developer release, which tends to work a little bit better with Macs, but because it is a development release, there could be some bugs in there, so just be aware of that if you decide to go that route. Now, something that I found interesting when I was looking at this was they also have a portable version. Now, I've done very limited testing with this, and so far it seems to work, but I, at this point, can't really recommend this, but once again, it's just interesting that they actually have a portable app now for Wireshark. So, capturing traffic. Where do you place Wireshark to capture the traffic that you want to see? What is important for you to actually capture in these packet captures? So if you're having a problem with a host, it usually is best to capture that traffic as close to the host as possible. So let's say it's a PC. I would install Wireshark on there and capture it there, because you're only going to see the traffic between that host and the destination that it's talking to. And sometimes that's enough to be able to troubleshoot the issues that you're having with a specific host. Now, let's say there's no way for you to get Wireshark on that host. It's a server that you don't want to install it on, or it's an iPad or an iPhone or an Android device. Then the switch is your next best bet, right? You're going to want to configure a span port, which is Cisco, or a mirror port, which is HP and most everyone else, to be able to capture that packet. And we'll talk about configuring those ports later on. A dedicated tap. I always like to talk about this because I can tell you that a lot of people don't have these. But if you need to capture traffic at high throughputs, the tap device is going to be your best bet. Only because when you're capturing Wireshark, or you're capturing packets with Wireshark on a machine, if you start to receive large volumes of traffic, like let's say a gig's worth of traffic, you're going to saturate that connection, and you're actually going to start dropping packets. So you're not going to get the whole picture of what's really going on. So if you actually have to capture traffic, like I said, at high throughput rates, you're going to want to use a dedicated tap. And then last but not least, the firewall. If all else fails, you can capture the traffic at the firewall. And like I said, we'll talk about that later on when we talk about configuring these devices. So as I said, on a Cisco device, it's called a span port. There's also the concept of a remote span port, but we're not going to talk about that. We're just going to talk about the span port today. There's a link there to a document that describes the process for configuring the span port. Sorry, I just heard someone chime in on the conference call. If you could, make sure that you mute your end so that we basically don't hear you. Appreciate it. So as I was saying, span port. Before I configure a span port on a Cisco switch or router or what have you, I always make sure that I do a show monitor first. The reason for this is if there is already a span port configured, you'll see it. And if there is, you may be able to use it. Or the other reason is to make sure that if you configure a new one, you don't use the same session ID. So as you can see in the example there, we're using session ID 1. So generally when I configure a span port, I always configure the source first. So you've got monitor session 1, or that could be 2 if you already have one configured. Source, interface, and then the interface that I want to source the traffic from. Then configure the destination. Monitor session 1, 2, 3, whatever. Destination, interface, and then the interface that you're going to be connecting to. Make sure that your sessions match, right? So if you configure a source for session 2, make sure your destination is also session 2, right? Like I said, make sure you do the show monitor first, and then that way you can be assured that there isn't any other session there. Now, something I always like to kind of point out, that when you hit enter on that second statement, your interface is going to drop out. You're going to lose connection to that switch, because now that interface is kind of beset in promiscuous mode, so you're not going to be able to talk to that switch. So when you're configuring a span port, you want to have one of two conditions. Either you're using a console cable that you're consoled into the switch with, or you have another port available to you. And usually what I'll do is I'll configure it on that other port, and then I'll switch to the port to do the capture. So just be aware of that. You're going to lose connectivity to that switch as soon as you enter in that destination statement. So configuring a mirror port on an HP switch, once again, we've added a link there to a document that explains how to do that. It's pretty simple. You configure the mirror port first. So the command is mirror-port, and then the port that you want to mirror. And then you actually configure the interface to be a monitored port. So it's a little bit different from the Cisco method, but still, it gets you there. So you got interface A1, and then you set that interface into monitor mode. And at that point, plugging into that interface will get you the traffic that you're looking for. So now we're going to move on to the firewalls, and I didn't go too deep into this because there's a video that explains how to do this. But if you want to capture traffic on an ASA, there's a wonderful YouTube video out there that explained the process to you. Also, we have the same for the sonic wall. There's a video out there that will also explain that process to you. So we're not actually going to go into that too deeply. Something that I did forget, and this was mentioned to me earlier, is that there may be some folks out there who have never installed Wireshark before. Just know that it's really easy, right? You download it, you double click on it, and accept all the defaults. The one thing that will pop up that will catch your attention and may kind of scare you a little bit is that it'll actually start to install another program called WinPCAP. That is required in order to be able to do packet captures. That basically sits on top of the network layer to actually pull those packets off the wire. So that has to be there, otherwise Wireshark won't work. So just know that when you see that pop up for that WinPCAP, it's okay to go ahead and click OK to install, right? And then once it's finished, Wireshark is ready to be used. So capture and display filters. The reasons for using these filters vary, right? Capture filters, definitely you're using it during a capture session, and display filters are being used when you're actually dissecting the data or analyzing the data. The first example is of a specific host. So this would be actually done on a switch or firewall. This would not be done on the host because that's all you're going to see anyway. So as I said, that is for specific hosts. So I'm saying IP.address equals 10.100.0.1. Now, I'm looking at both source and destination for that IP address. So any traffic bound to that IP address or any traffic from that IP address, I should be able to capture with that capture filter. There really is no reason to do a destination or source IP address unless you're looking for something very specific. And to be totally honest, if I was going to do that, I probably would be on the host itself. But just know this is going to capture both source and destination to that IP address. If you want to configure a capture filter for a specific port, the example there is for DHCP traffic. DHCP traffic will be seen on port 68 and port 67. So by defining that capture filter, that is all the traffic you're going to see in that capture will be DHCP related traffic. So it's going to be the requests and the replies and the broadcasts. You're going to see all of that. The third example there was a very specific capture filter. And I usually don't go to this level, but in this case, this was the only way to get the traffic we needed. So I'm going to explain what this filter is, and then and why you'd want to use it, right? So basically, the filter reads: I want to see I want to capture all UDP traffic or TCP.destination not equal to port 80 and destination or TCP.destination port not equal to 443 and TCP.source port not equal to 80 and TCP. Sorry, that should have been source port. Yes, correct. I'm sorry. I'm losing track of what I'm saying. So TCP.source port not equal to 443. So essentially what you're saying by the statement is I want to see all UDP traffic or all TCP traffic that is not sourced or destined to 80 and 443. So essentially you're saying I don't want to see any web traffic, but I want to see everything else that would be in the TCP protocol. The reason for this particular filter had to do with troubleshooting an issue with a network that we believed was not web-based. It was some other random port that was causing the problem. And this was the easiest way to get that data without actually knowing what the port was. Okay. So display filters. As I said, display filters only get applied to traffic after it's been captured. You're analyzing the traffic. And you want to limit what it shows up in the display window. The first one is http.response.code greater than 400. So with that display filter, I'm basically asking it to only show me HTTP responses, meaning the response back from the server that's greater than 400, which I know is an error, right? Except for maybe 403. 403 can be an error, but it's sort of a recoverable error, so it's not really a bad error. But 404, 500, and so on are non-recoverable errors. So that's the reason for that particular display filter. The boot P, once again, I'm asking it to just display DHCP traffic and nothing else. As I said, capture filters for capturing traffic, display filters for displaying that traffic or analyzing that traffic after the fact. You also have these analytical tools built into Wireshark. The expert info, which we'll look at later, basically shows up as sort of like a little button down at the bottom of the GUI that you can click on, and it'll bring up errors, warnings, notes, and so on. The statistics, protocol hierarchy, conversations, and IO graphs. Protocol hierarchy basically just displays all of the packets broken down by protocol, and I'll show you what that looks like. Conversations, looking at traffic to and from specific hosts. And then IO graphs are for visualizing traffic. And like I said, when we get into the UI, I'll show you examples of all of these. So TShark. This is something I promote quite a bit when I'm out in the field and talking to engineers, because TShark exists both in Unix but also in Windows. And TShark is, I think, sometimes a better way to capture traffic, because sometimes the GUI can get a little flaky. Sometimes it'll crash in the middle of a capture because a buffer fills up or something weird. I mean, that has gotten a lot better, and it doesn't happen as much as it used to, but it still does happen every once in a while. So by using TShark, you can actually capture that traffic, without the GUI, and then later on open it up in the GUI to actually analyze it. Okay. So if you actually want to see what options are available for TShark in Windows, if you go to the program files, right? So it's going to be in C program files, Wireshark, tshark.exe /?. That will show you all the options for TShark. Now, if you installed the 32-bit version of TShark, that's going to be program files x86, right? Because that's where all the 32-bit applications get installed in Windows. The same for Linux. It's just tshark --help will show you the options, or if you want some more in-depth details, you could do man tshark, and that will actually bring up the manual for tshark. So some of the options that I use quite a bit are -I, which is how you define the interface for TShark. So it's either going to be, the interface in Windows, which I'll show you what that looks like, and then the interface in Linux, which is usually like, ETH0 or ETH1, or in the newer versions like CentOS 7, it's like EM0 and EM1. The ring buffer options, -B. This is useful when you're doing either continuous captures, or you want to make sure that you're actually able to read this after you're done, right? So the ring buffer, there are two options that I use in the ring buffer options. One is file size. I'll define a file size for each capture, and at that point, create a new one. And then I'll set up a ring buffer to actually keep X number of files. And like I said, I'll show you what that looks like in a bit. The -W, write this output to a file somewhere. You give the file a name and a location. -F, if you want to actually set a capture filter. Now the last two I threw in there because sometimes they're useful, sometimes they're not. The -R, if you want to read a capture in TShark, you can do it, but I recommend you use the $Y. Otherwise, that information is just going to scroll past you, and given the size of the display buffers in even in an SSH session or in command window, you probably will miss what you were looking for. So just know that if you're going to do a read with TShark, you're going to want to actually use a display filter. So as I said, you can go ahead and configure TShark in Windows, and I went ahead and actually created a shortcut on my desktop that automatically launches with all that information in there for me. So all I have to do is just double click on it. Okay, and as you can see, that's a shortcut, right? But what you can't see in that target window, I put over on the side, so you can see I got the program, so it's C program files, Wireshark, tshark.exe, and then I defined the interface. That's how Windows defines an interface, and I'm going to show you how to find that. -B for the ring buffer option, file size 850 megs. I will tell you that anything beyond 875 megs will actually crash the GUI when you're looking at it. So I always make it less than. Okay, and then I'm keeping 5 of those 850 meg files. Now, just know that if it doesn't reach 850 megs, it's not going to create a new file. So don't be concerned that you're going to have a bunch of files created. But let's say there's a lot of traffic, right? This is the way of making sure that something doesn't get dropped off, right? And then the -W, write this to a directory, and then that's the name of the file being test.pcap. And you always want to use the pcap extension. You could also use the pcap-ng extension, which is actually the new extension for Wireshark captures. And what the ng adds to that, and even if you don't put the ng on there, the fact that you've captured it with a new version of pcap will actually make it ng. So don't get confused. You could always use pcap or use pcap-ng. Is it gives you the ability to actually comment inside of a packet capture, so you can actually put comments alongside a specific frame, or a comment that just basically sits with the entire packet capture. So like I said, in order to find out the name of that interface, if you do a tshark-d, it's going to show you something like this. So you can see if you look halfway down there, you'll see where it says local area connection. That is the name of that interface, and that is what I have configured in my entry. Something to be aware of is to make sure that you have open and closed curly brackets. As you can see in my example, you don't see the open curly bracket there in that display, but you do see the closed curly bracket, which is kind of confusing. But just know that when you add that name to your shortcut, make sure that you have open and closed curly brackets. Okay? And you never really want to capture traffic on a Windows box on the wireless interface, because there is no way for you to set that interface into promiscuous mode. Okay? Unless you have a special card with a special driver that would allow you to do that. Folks like Wireshark
is in bed with somebody.
Yeah, that has the cards, that has the drivers. Yeah. So, but on a Linux box, you can capture traffic on a wireless interface because it will allow you to force that wireless interface into promiscuous mode. But you have to use special drivers once again. But in Linux, that's very possible. In Windows, a little bit harder to do. Yeah. So, as I said, you've got your shortcut configured, right? You go ahead and you double click on that shortcut, and this window will pop up. Those first two errors, I will tell you, I've never seen those before. Those are new. I actually updated my version, so I'm wondering if it's an issue with the version I'm running. But it didn't seem to affect the capture in any way. That 134, that's actually incrementing. It started at 0 and incremented up to 134 when I finally took the screen capture. Just know that that number will continue to increment based on the number of packets that are captured during that session. And as you can see, I am capturing on a local area network. Or, sorry, local area connection. In order to stop this capture, Control-C will break out of that, and the file will be found, in this case, ctemp/test.pcap. Okay, so just be aware of that where you set your location for your write, that's where your pcap file or your capture file is going to be. So be aware of that so that you know where to look for it. So Linux, similar command line, TShark-I for interface, ETH0, which is the primary interface on a Linux box. If I had a secondary interface, it would have been ETH1. Dash file, the file size, once again, 850 megs, 5 files, and then I'm writing it to /temp/test.pcap. And when you hit enter, this is what you're going to see, right? It's going to tell you you're capturing as root. This could be dangerous. I can tell you that, yeah, I guess it could be dangerous, but I've never found a problem with it, so don't worry about it too much. You can see that it's capturing on ETH0, and at the time of the capture, when I took the snapshot there, I had 44 packets. So there was a lot less going on this Linux box when I did TShark than there was going on my Windows box, because the captures were about the same time. I mean, as far as duration. Okay, so let's go ahead and we're going to hop into the UI and take a look at some packets. So I've got some captures that I'm going to go ahead and throw up, and we'll, like I said, we'll take a look at them, and I'll go ahead and go through those features that I mentioned earlier. Okay, so here's a packet capture that I did, and if you look at the title of the file, you can see that it was an FTP capture. I like to name mine based on the traffic that I'm capturing, so that makes it easier for me to be able to determine what it is. Now, let's say you did capture it as test.pcap. You can always rename it later, right? But I like to keep these things around, so I always name them with something that I'm going to understand. Okay, so as I said, this was a packet capture of some FTP traffic. The expert info, as I mentioned earlier, is this little radio button down here. This radio button will be a different color based on the type of information that's contained in the expert info. Red is for warnings, red is for errors, yellow is for warning, blue for chat, which basically is just almost the same thing as conversations. So I'm going to go ahead and I'm going to click on it. And when I do, what opens up is this window. And you can see there weren't any errors, which is the reason why it wasn't red. There weren't any warnings, so it wasn't yellow. There weren't any notes. This is the other option that I can't remember the color for this. I wanted to say it was green, but maybe not. And then chats was the only thing that it saw, and I said when I click on that, you kind of see conversations. And then details basically gives you more detailed information of every single packet in that capture. I will tell you the only reason I ever really use this is when I see it turn red or I see it turn yellow to see what those errors and those warnings are. Everything else just doesn't really matter much. So as I said, this is a packet capture and FTP session. And the reason why I like to use this one in my demonstrations is because lots of times folks don't understand why we shouldn't still be using FTP. Right? So if I go in here and I could actually just do it this way, I could type in FTP and hit enter. That filters, that was a display filter on FTP traffic, right? Now you could see this first line, this is a response from the FTP server, and then you could see I put in my username, anonymous. It said guest access okay, what's your password? I put in guest as my password, and then they let me in, right? Not a very secure FTP server, but if I really wanted to look at this, you actually use the dissectors that are built into Wireshark to actually look at this traffic in a much friendlier way. I could actually do a follow TCP stream. At this point, it will actually open up another window that gives you the reader or the friendly version of that same traffic that we were seeing there, basically packet by packet, right? You can see that the server responded 200 okay, right? That means everything's good. What's your username? I put in anonymous. It said okay, guest login is okay. What's your password? Well, if guest login is okay, I guess any password would work. Generally, these passwords have to almost kind of look like email addresses, and they do look for that @ sign lots of times. So I always just say guest @ or Mickey Mouse @ or whatever I happen to be feeling like that day, because I don't think anyone's really watching this, to be totally honest. You know, if you have guest access to your FTP server, you really don't care about security. But the point I'm making is, let's say this was not a guest access FTP server. What if this was an FTP server within your network and you were actually storing, you know, pertinent information on this FTP server? Well, the whole session is in the clear. So if I can capture that traffic, I now have a real username on your network, probably, and their password. So I could use that. It may be their Active Directory password. So now I can log into your domain, and anything they had access to, I now have access to. And if you happen to be vulnerable to some privilege escalation vulnerability, now I can try to escalate my privilege to administrator, because I have access to your network, because I have credentials that are usable on your network. So as I said, the dissectors in Wireshark are very useful when you're analyzing traffic. You can pick these bits out, you know, within the actual packet streams. Sometimes they're a lot harder to pick out than others. FTP is a pretty easy one. We'll actually go ahead and we'll look at one for, I'm going to go ahead and open up a different packet capture here for a different type of in the clear session. Okay, so once again, you can see by the name, this is a telnet session. If you didn't know that, it'd be pretty easy to pick it out. I could probably go ahead and use a different display filter here. So I could say port 23. See if it's going to let me do it. No, it didn't like that. I could do telnet. That would work too. So you can see there's some telnet data in here, right? Like I said, not as easy or decipherable as the FTP data was, right? But I can still use the dissectors on this. Follow this TCP stream. And here is a telnet session in the clear. Once again, Had it required a username, you'd be able to see it there, and you could see that the password I typed in was Y in the clear. Once again, dissector is very useful for analyzing traffic when it's not as easy to read by just looking at the contents of the packets themselves, right? And if you look at this one, in the expert info, it's actually yellow, so there actually is a warning. So let's go ahead and take a look and see what that is. And there's actually 3 warnings. One is seeing a duplicate IP. So more than likely, there's probably a misconfigured machine on the network, because you should never see a duplicate IP. There was some connection resets, or actually 1 connection reset. Probably not a big deal. And then once again, duplicate IP again for a different host. So once again, by looking at the expert info, you could see that there are at least 2 issues on this network that I wasn't even looking for that it found. So expert info sometimes can be very helpful. Sometimes, like I said, there's things in here that probably aren't an issue. Like you'll see some errors that will talk about not being able to see the previous packet, and that is mostly due to when the packet capture was started, because it could have been started in the middle of a session. So of course you're not going to see the previous information because it's not there, right? So like I said, when you see these warnings and you see these errors, you kind of have to know what you're looking at, but because a lot of them really aren't. So just be aware of that. So let's take a look at a different one. This one's slightly more complicated. This is actually an HTTP download. And once again, given my file name, you can see HTTP download slow, which means that's what the problem was. But let's try to see if we can figure out why it's slow. Okay. As I was saying, you got the expert info, so we'll go ahead and we'll take a look at that first, see if there's anything there of value for us. So we got transmission window is not completely full. Like I said, these resets may not be a problem. Definitely the window's not being full could point to a problem, right? 0 segments. But this is that one I was talking about earlier, right? Previous segment not captured, right? Could be when it actually started, so there was packets they were lost as part of that, so or part of that conversation, right? So let's look at some statistical data on this. So we're going to go ahead and look at the conversation. And we're going to look at the IP conversation, and you could see that for the most part it was this host talking to a bunch of different servers. So by looking at this, you could assume 2 things, right? One, either this was captured with a capture filter that was only looking for that IP address, or this was captured on the host itself. And I'm going to believe that this was captured on the host itself because I think that's where I captured it. So, but you can see it's talking to a whole bunch of different addresses, right? Now, just to kind of give you some background on this particular capture, this was actually a download, right? As I said, it was a slow download, but it was a download for an application that apparently had a bunch of mirrors, right? So that's what it's doing, is it's talking to all these mirrors to get the application that I was trying to download. Okay. So as I said, that's conversations. So let's see if we can visualize some of this data. So we're going to go to statistics. I'm going to go to IO graphs. And this is what the traffic looked like. Right? So you can see there was the ramp up, right? Traffic started coming in, it was coming in, and all of a sudden it drops out. Right? Then it picks back up, it's coming in, then it drops out. And this one's a lot longer. Then you get a little blip of some data coming in, drops out, and then it comes in, and then it finishes. Okay? So let's see if we can figure out why this data looks like this. So I usually like to use my my favorite is usually TCP dot this, and I'm going to look for retransmissions. And I always like to convert this to an F bar, which is basically just going to throw a line in there. And I'm going to leave it as the color red, and I'm going to go ahead and turn it on. So you can see there was a retransmission there at that point. So that was probably a packet that got lost that it retransmitted before it would actually continue on with the download of the packet, right? So that was a retransmission. So let's see if there's anything else interesting in here. And this time I'm going to look at duplicate acts. And I'm going to leave that as green. I'm going to turn it into an F bar. And you can see there at that dip, right, which was a problem that we can acknowledge that there was a problem there. There was a duplicate acknowledgement, right? So that tells me that the two sides weren't agreeing as to where we were in this download. So there was a duplicate acknowledgement for a packet that was received from either one or the other side, which is what probably prompted that stop of traffic flow to get that retransmission, to make sure that all the packets were there so that we can continue on with the actual download. So like I said, I/O graphs allow you to visualize the data. I would say that, you know, some of this stuff that I'm throwing out there is probably not introductory, right? It's probably a little bit more advanced, but I think that sometimes people need to be able to visualize the issues. It's easy enough for me to go through this packet capture and I could find those retransmissions and I could find those duplicate acts. And, you know, for me, it's easy enough to do. But for some folks, when you're looking at this, it's really hard to pick out those issues, right? It's kind of hard to go in here and actually find those. Even if you go ahead and you use the dissectors, you're still not going to be able to see those issues either. You're going to see basically gets, so this is a request, and a response. So you can see I requested something from the server. The server said, okay, I'm listening, and it sent some data. And then here was another request. Here was another response. It sent some more data. Another request. Here's a response, and it sends some more data. But within that stream, can you see a retransmission? Can you see a duplicate act? No, you can't. So, like I said, sometimes you need to use the other tools that are available to you in Zscaler. Sorry, got Zscaler on the brain. Wireshark, to be able to visualize the data differently so that you can actually get to the problem that you're seeing. So I'm going to go ahead and bring up a different example here. And we're going to look at one of the other tools. Like I said, we're going to look at the protocol hierarchy. So I'm going to bring this one in. And if you want, don't look at the name. But statistics, protocol hierarchy. I like to use this particular tool when I'm looking for traffic and I may not know the right display filter to use, right? So let's say I'm looking for some TCP traffic, but I'm unsure of the actual display filter to use, right? And this one only has HTTP traffic in it. If this was a larger capture, you would have seen some DHCP traffic. You would have seen some UDP traffic. You would have seen other types of traffic. But this one is kind of easy to kind of just to kind of show the concept that I'm trying to drive home here, and that is that from within here you can create display filters. So by right-clicking on a protocol, I can go ahead and apply it as a filter, and I'm going to say selected, and you can see that it creates a filter for you based on that traffic. So you can see HTTP, TCP, IP, ETH, frame. So basically, it was going up the stack, that we were in to craft a display filter to just show that traffic. And as you can see with this one, it was actually a get for OpenOffice. And if we were to look at the conversation for this, I'm going to go ahead and clear this filter. You're going to see something similar to what we saw with the other download, that one host is contacting, well, actually, in this case, sorry, it's one host. So it wasn't a mirror in the case of this one. I thought it would have been. But as you can see, I was proved wrong by conversations that it was actually talking to one host when it was doing the download. But this one actually has a different problem. It actually has an issue where it's actually dropping packets. So once again, difficult to see here. But if you actually visualize the data, you could actually see those packets being dropped. Which we won't do right now because I'm getting close on time and there's some other things that I actually want to get to. So kind of to shift gears back into introductory mode, within Wireshark, and forgive my pauses, every time I go to speak, Zscaler wants to come out of my mouth. And that's because I've got Zscaler on the brain. So just be aware that if I actually accidentally say Zscaler, I mean Wireshark. So something that's kind of nice, kind of cool within Wireshark is you have the ability to create buttons. And you create these buttons based on display filters, right? So let's look at that one I had earlier, which was http.response. Response code, right? So let's say I wanted to go ahead and create this, so greater than 400. You can see it's a valid filter because it turned green and didn't stay red, right? I can go ahead and copy this, and then if I go to Edit, Preferences, you'll get this pop-up. And if you look under Filter Expressions, you have this ability to create filter expressions that show up as buttons on in your GUI. So we're going to go ahead and we're going to create one real quick. New expression, we'll call it HTTP errors. Oh, sorry. Let me take that back. Did that wrong. That's that. And I'm going to call this HTTP errors. I have to learn how to type. Okay. Then I apply that. And you'll see sorry, I had a pop-up that I need to acknowledge. But you can see now I have this button here. So whenever I want to look for HTTP errors greater than 400, I don't have to type in that filter anymore. All I have to do is load my file and hit this button. And it will automatically go in there and filter based on that display filter. And I'm going to show you a different capture that will actually be more beneficial with that particular display filter. So here's a different capture. And here's my button that I created earlier. And when I click on that, you could see that it filtered out all the traffic except for everything that had a response code greater than 400. Okay? In this case, the response code is actually 500, which is an error. It's an internal server error. And basically, this was the server saying, I can't talk to you right now, for whatever reason. We won't actually go deep into this packet, but just know that these display filters can be created beforehand. So if you have a bunch of display filters that you use all the time, it would make sense to go ahead and create all these buttons so that you have them available to you when you want to use them. And that is definitely a neat new feature in the it's the release that was in the .12 release, so it's 1.12. I'm currently using .2, and actually I think they might be at .6 at this point. I will tell you, I am not a fan of jumping on the upgrade bandwagon with Wireshark. I usually run a couple revs behind, but I never install 0. It's always a good idea never to install Rev 0. Always wait for Rev 1. I will probably go ahead and upgrade to Rev 6 only because it seems to be pretty stable. I haven't heard of any bad stuff with it. I just haven't gotten around to updating it yet. But just know that if you have a working version of Wireshark, continue using it. Don't upgrade it every time it tells you there's a new update, because it will tell you. You'll get a little pop-up saying, hey, there's a new version of Wireshark. You want to download it? It's not a big deal because it will always uninstall the old version before installing the new version. But just know that if you have a stable version of Wireshark that's working, there really is no need to update unless there's a new feature that you want. And there are feature releases. Usually the release notes will indicate what those features are. Then you can make a decision whether or not you actually want to upgrade. Okay, so that's buttons. Another thing, and I know you probably don't see it in this one, so I'm going to actually go ahead and close that one. I'm going to clear this. Is all these little neat colors when you're actually looking at the traffic. These are also configurable by you. Once again, I could use that exact same display filter that I created earlier, and I can create a coloring rule so that at a glance, I could see the color that I've defined as HTTP errors when I open up the packet. I will tell you, sometimes this gets a little bit muddy, and I like to use this sparingly, because when you have a bunch of colors in there, it's very distracting, and it's hard to figure out what you're looking at sometimes. So just be aware that this feature is here. You can use it, but use it sparingly. I have a few in here, which I tried to zero these out, but unfortunately it wouldn't let me. I actually am loading a different profile, which took away all my buttons. I actually have like 15, 20 buttons in mine. But these would not zero out with the new profile. So you can see this one here, this bad TCP. This was actually one that I crafted based on a display filter. And let's see where else. This one was in here by default. That one was in there by default. Actually, I don't see all of mine. The only one I'm seeing is this one. So maybe it zeroed out most of them, not this one. Maybe I had this one in my default profile, and then I decided to make a new profile to put all my new stuff in. But just know that you can create these coloring rules, and they can be useful in certain circumstances. Let me go ahead and I'm going to pull up one more. Okay, so here's another capture. Once again, title gives it away. It's an ARP issue, but how can you tell, where the problem is? In this case, I believe, let me take that back. Yeah, actually, because my coloring rules aren't in here, you're not going to see it. So I actually have a coloring rule that looks for issues with ARP. Unfortunately, we're not seeing it here, but by looking at this, I should be able to tell you what the problem is. Wait a second here. Okay. As I scroll down here, you can kind of see a recurring theme, right? You're seeing a bunch of different people. ARP basically, what ARP is basically how machines find each other on the network, right? They send out this ARP and say, who knows where this IP address is, right? So when we actually scroll down through here, you see a lot of different addresses, but you start to see sort of a recurring theme. You start to see this guy a lot. 10.10.0.1. You see him constantly ARPing for different addresses. Why? Why is this host trying to basically interrogate the network to figure out where all these other hosts are? You know, really, there's no reason to, because you're not going to communicate with everybody on the network. Usually, your traffic is very specific. You want to communicate with the DNS server, or you want to communicate with the Active Directory server, or you want to communicate with the file server or a printer or so on, but you don't want to communicate with everybody on the network, all right? There's really no reason for that. This is a gratuitous ARP. So basically, this guy is interrogating the network to try to figure out where everybody is. Okay, and then the response usually comes back with, he is here. And generally, it's the switch with the who owns the port, or the router who owns the route to where the port is, where this guy is located. So that basically, like I said, is the purpose of ARP. And when you see a gratuitous ARP, meaning that there's one host that is just asking a lot of questions, there's something definitely wrong there. Okay, and the last one I want to look at is a capture of CNN. And the reason why I like to look at this capture, because sometimes you need to know what traffic looks like to be able to understand when it's wrong, right? In the case of CNN, there are definitely a lot of requests. So we're going to go ahead and we'll filter this by HTTP. You can see a lot of GET requests when you go to CNN.com. This is normal. And what I mean by that is when you go to a site like CNN or Yahoo or some sort of portal site, there will be a lot of requests for content. So seeing a lot of GET requests when you're going to CNN is normal. But if you're going to a website that's pretty static and you're seeing a lot of GET requests, there may be an issue there, right? Because that may not be normal. So you would actually have to analyze each one of these GET requests to try to figure out what is being requested, you know, and whether or not that could be malicious. But like I said, in the case of CNN, it's a portal site. It's displaying tons of content. So this is normal. Okay. So we're running out of time. So I want to basically show you where you get help, right? Wireshark has a wiki. In this wiki, there are links to, you know, crafting capture filters, crafting display filters, the different tools available to you. The TShark was the only one I touched on, but there are other command line tools that you can use. Some of them are useful, some of them are not so useful, and some of them just, the data's already in the GUI, so you really don't have to use it. Like packet counts or packet information, things like that. That can all be gotten from within the GUI, so you don't really need to run these command line tools against a packet to try to get this information out of it. But the thing I did want to point out on this help site is that they also have a link to sample captures. So sometimes your network is somewhat boring, right? There's really not anything interesting to look at when you do a packet capture. You can actually download these sample captures. They'll have some pretty interesting traffic, and you can go ahead and take a look at that. So if you feel kind of squirrely, and you got nothing to do for an hour, because I'll tell you, once you go down this rabbit hole, it's kind of hard to get out. When you start looking at packet captures, depending on how you're wired or driven, you can spend a lot of time doing this. So make sure you have the time to do it. But definitely looking at these sample captures will give you an idea of things that should not be on your network. Okay. So at this point, I want to go ahead and open up the floor for any questions. Please use the chat.
We have a question here.
Okay.
About the help flag.
Okay, so we have a question about the /?, and I'm assuming this is in Windows, right? Because it's not available in Linux, right? So the /help, so it would be TShark space or tshark.exe space /?, would give you the help for that particular tool. It would work with any of the tools, the command line tools that are available to you. When you look at in that programs directory where Wireshark is contained, you'll see all those other exe tools in there. Like as I said, one is like cap info, which basically spits out the information of the packet capture, or they have packet count, which lets you spit out the number of packets within that packet capture. There's various different tools, but like I said, all this stuff can be gained from within the GUI, and sometimes it's just easier to just open up the packet capture in the GUI and look for that information there. Any other questions?
Another person was mentioning that latest stable release is
6.
6.
Yes.
And that's probably per the Wireshark website.
Right. Yes, the latest release is 1.12.6. And I would say that there wasn't anything new in that release that I was interested in, which is probably why I didn't jump on that release.
Okay, and we have a chat from another person saying on Windows it looks like it, and I don't know if this is version specific, that
right.
It looks like it needs to be a
dash question mark
instead
okay.
of a / question mark.
So,
Windows is never consistent.
Right. So just be aware of that. Depending on what version of Wireshark you're using, the dash question mark will work where the / question mark will not. We still have some time, so if you have questions, definitely feel free to go ahead and ask. The slides and this recording will be available. If not later on today, sometime tomorrow. We need to go ahead and probably just edit out some dead space in the recording, because we started recording before we actually started speaking. So just bear with us to go ahead and get this edited, but we will get that out there as soon as possible, as well as the slides. Do we have any other questions? Oh, looks like we got one coming in. Well, less of a question and more of a thank you. Thank you, Sonia. I appreciate it. If there aren't any other questions, we'll go ahead and end this recording. Just like I said, look on the website. It's www.mcnc.org/CNE-webinars. All of the webinars for the summer webinar series will be contained at that link at some point after they're completed. So just stay tuned. Thank you.